in a transactional boundary. So I use @transactional. That tells Spring to wrap the method invocation in a transaction, commit it if everything succeeds, or roll back if it fails. I can put @transactional on the class so that all methods assume that behavior. It's very common nowadays to want to be able to save state, right? To save access time. And did you guys see the Gradle's Play Smackdown yesterday? You guys didn't see that? Oh, it was awesome. They had this, the takeaway was, the thing you should remember was, caching is an awesome thing to do. Caching will save you, your application, a lot of performance. It will give you a lot of performance, a lot of speed. So in Spring 3.1, we introduced the Cache Manager API, okay? So here's @cacheable. When somebody invokes this method, the result of the method will be saved in the cache under a key derived by a key that is created by using the arguments, okay? You can tell Spring that I only want to use the first argument or the second, but basically by default, it'll just take all the arguments and create a composite key and use that to create the cache. So if you call this method with ID 5 or ID 10, the key is 5 or 10, and it's stored in the cache for you. The cache is pluggable, of course, right? So you can plug in whatever cache implementation you like. It's very natural then to want to be able to take that, take that service and inject it into a controller, Spring Mvc, right? So how many of you guys are doing RESTful services? Oh, awesome. So good. I'm so happy. You go to some countries and they're like, REST, quoi? Huh? They've never heard of it. So yeah, this is a Spring Mvc controller, very, very simple. I've got a request mapping at the top of this method. When Spring Mvc sees this class, it will look at the method, it will expose this method by that URL. So customer / that's called a curly bracket, ID curly bracket. That's a path variable. The ID is a path variable. Spring will look at that and treat it like a regular expression or a pattern match. It'll take all values that are in that URL and then apply that and make it a variable, make it available as a variable in the argument, in the method arguments. So @path variable is the value in that URL, okay? And that's sort of like the 80% case, right? That's what a lot of us are doing. We're building applications, talking to databases, and those applications are something that can be consumed on the web, right? So here we have a RESTful endpoint for that. Of course, the obvious question is, where did that session factory come from? What about the cache manager? Where did all this stuff come from? I can't just show you code with just the basic class and not show you where the configuration is, right? And as you guys know, in Spring, configuration gives you flexibility. It gives you the ability to plug in different types of objects based on your use case. It's very common to use XML. A lot of you guys are using XML, that's cool. So here's an example of, public static void main. It's not dead. You can still use public static void main. Life is good. I have an XML file here. I'm going to get access to the bean. This is something we've all been doing for years, yeah? In the Java configuration world, you use an annotation config application context. So instead of an XML file, I pass in a class reference, okay? That class reference will have all the metadata that Spring needs to configure the beans for you. Here's a typical XML sort of Spring configuration. Lots of little pieces here, lots of little features. We have support for transactions, declarative transactions, right? So TX : annotation driven. Remember, Spring provides a lot of features, right? The features are very easy to use. They need to be turned on, however. You need to turn them on. You need to enable them. We don't assume, we don't expect that you want this or that. So you have choice. If you use a Java bean in Spring, we don't serialize it and make it transactional and all that stuff by default because it doesn't, what if you don't want that? So if you want it, you have to turn on the feature. One little line, okay? TX : annotation driven. I want Spring to look in my package. I want it to look in the package, find all the beans in the package, and then register them for me. Very convenient. I want to be able to use values from a property file. So config.properties. You can see in the data source. In the data source, I have $ds.user. That's a template variable. It's a variable. It'll be substituted or replaced using the config.property value. And then, of course, I have regular Spring configuration. I have 3 different beans, and the beans depend on each other, okay? So we've seen this stuff before. Here's taking it from the top now, starting again. Here's a regular XML file. Here's the equivalent Java configuration so far. So it's just a regular class with @configuration at the top, yeah? I want to reintroduce my transaction management, right? I want to be able to declare transactions in my application, and I need a transaction manager. Remember, Spring doesn't just assume JTA. If you want to use JTA, you can. You can use JPA, AMQP, JMS, JDBC, JDO, Hibernate, whatever. Lots of different types of transactions, so you need to specify a transaction manager. Here we have the Hibernate transaction manager. In Java configuration, you just use @enable transaction management. That enables transaction management for you. And you don't have to specify the bean because you can just find it by the type. So @bean public platform transaction manager. When Spring sees the @bean method, it invokes the method, takes the result, puts it in the application context, and then that bean is available for injection, just as if you had, it's the same as if you used XML, okay? Except now you can use full Java. You can use all the power of Java. Our transaction manager references the session factory, right? This session factory is a dependency that we have on one bean in another. In Spring XML, you would say property name session factory, ref equals, and then the bean name. Well, here, you just call the regular bean method. Just call the method. It will invoke the method, create the bean, satisfy the dependencies, fully configured and initialized, and then give you the returned reference. If the bean has a scope, then the beans will be created in accordance with that scope. Okay, so if you have a singleton bean, it doesn't matter if you call this .session factory 5,000 times, you only get one instance. So you only pay the cost of creating it once, okay? The semantics, the rules of working with the beans is the same as in XML. You can call the method, that works, that's fine. Or optionally, you could just declare an argument. Okay, so here I'm saying to Spring, I'm going to try and create a platform transaction manager. To do this, I need an instance of the session factory. So find the type in the context and then inject it for me in my method. And this will be made available, so I can use that as well. The same result though. I have a fully configured session factory ready to use. Okay. Before I had component scan, it said context : component -scan in the XML. Here I'm using @component scan, the annotation. And instead of using a string for the package name, I'm telling Spring to just look in the same package as this class. Okay, so this will take the class and it'll look at the package for that class, and then it'll find all the beans below it. I can use a string if I want, of course, but I think this is more refactor friendly. Property placeholders. This is a very common use case. People want to be able to change the values from one environment to another. Here we use context : property placeholder, and then we reference a properties file. We can achieve the same thing in Java configuration by using @property source at the top. Okay, @property source at the top tells Spring to look for a property file, and then we inject a reference to a environment object. The environment object is a Spring API. It's a Spring object. It's something that's there if you want it, okay? When you use the environment object, it has access to all the properties that you've configured, all the property sources, okay? Including config.properties. So you see in our data source, we use environment.getProperty ds.user to obtain the value for that property at runtime when the application is started up. So it's the same effect, the same result, just a slightly different API. We saw the session factory, of course. The session factory is just another bean. So you can see how this all kind of plays together. Oh. Merci. Yeah, let's see. Okay, so any questions on that before we move on? I wanted to make sure we're all on the same page about just a basic translation. You should be able to look at the XML, close your eyes, and then you see the code in Java. It's very easy to map back and forth, you know. You can use XML with Java, of course, and the annotations. You don't have to choose one or the other. The XML will be there for years. It'll never go away, so you're fine. But I think this is a very nice approach, and if you want to incrementally, slowly add Java configuration, you can, okay? Yes, sir, you in the front.
This approach is simpler and as adaptable as the XML approach.
I think so.
You have this dot environment, so you don't have to change the code to some property changes. So it's better, in my opinion, to use this than the XML approach.
Well,
a new project. It's a question.
It's in this case there. Oh, the question is it better to use the Java configuration approach and the property file from the environment so that the values don't have to change? In both cases, in the XML here we have the property file, right? So property placeholder config.properties. That's also an external property file. You can put that in the file system. It doesn't have to be on the class path. And then in Java configuration, same thing. So the result is that they're both equally as flexible, okay? There is one use case, which we will talk about shortly, that is a little different. You can't keep, with XML, you could, in theory, keep the XML outside of the WAR. With the Java class, that's a little more difficult. But we'll look at how to solve that soon as well. Okay, any other questions? Does that answer?
Yes,
okay. Okay. Yeah, any other questions? Moving on. Another feature we introduced in Spring 3.1 is support for testing, okay? We'll look at something called profiles, but when we upgraded our testing support, we introduced support for Java configuration as well. So here, JUnit and Spring will load your application context and then let you inject the beans into your unit test. This is the same as we had before with the XML. We also have something called profiles. Profiles solve the other problem. They solve the other use case of, okay, I want to have one bean in my application and I want to define it differently for development or production or Q&A or the cloud or whatever, So if you're testing something, maybe you want your embedded H2 database. But then in production, maybe you want Postgres or MySQL or whatever, okay? In this example, here in the XML, I have a beans element at the top, and then inside I have two beans elements inside. And the beans inside say profile equals production. It doesn't matter what you use as a string. You can say production or foo or bar or whatever, okay? And then below I have embedded. So these are two different ways of declaring the same bean, a data source, right? One is using a driver, a data source driver, and the other one is just using the local namespace for creating an embedded local H2 in-memory database. I can activate the profile. I can say at runtime, this profile is active and thus all the beans inside the profile are active as well. I can have 10 beans or 1 bean or whatever inside a profile, okay? You can also do this in Java configuration. So here's an example of two different Java configuration classes. One for profile embedded, one for profile production. They both define a data source. They both produce a data source that I can import. But based on which profile is active, I only get one reference, right? So in my class below, I import both of the configuration classes, but then I declare dependency on a data source, and only one will be returned, depending on which profile. If you activate both profiles, which you can do, you can activate 5 profiles at one time if you want. If you activate both profiles, and they both have a definition for the data source, you get a conflict. Just like you would if you define the same bean in XML twice or in Java configuration. Questions on that? Okay, moving on. Cache abstraction. I mentioned this a little earlier. The cache abstraction is something that we introduced. It provides two key classes, cache and cache manager. Cache manager maintains a reference to the actual connection, the client-side connection to a data cache, like EHCache, Gemfire, Coherence, Infinispan, Hazelcast, whatever, right? Lots of options. And any JSR 107 compliant cache as well. So you can use that. Cache itself, the cache object, represents a region in a cache, an area, okay? We don't support things like configuring expiry. We don't support things like supporting, the write-through patterns and that's something that you have to configure in the cache server, in the cache, cloud, cluster, whatever. That's different from this side. We're consuming here. We're just a client, okay? Lots of different options, as I mentioned. If you were using Spring Core, we ship with support for EHCache as well as java.util.concurrent hash map. And most data cache products have an interface that is compatible with java.util.map. So if you're using something we don't have support for, you can just plug in the map interface and that'll still work. If you have JSR 107 supported implementation, there are very few right now, but there will be when that standard becomes available. Then you can plug that in as well. If you're using Spring Data Redis, you can use Redis. If you're using Spring Data Gemfire, you can use Gemfire. If you're using for example, Hazelcast, from Hazelcast, they have an implementation. If you're using Infinispan from JBoss, they have an implementation. There are lots of implementations. So Memcache, there's a Memcache implementation. So plug it in, no problem. And of course, it's very natural. You know, maybe in development, I just use a map. But then in production, I point to some big cache, you know, profiles. Use the profiles there. So here's how that looks. Okay, several methods. Service methods, I have @cacheable. The method gets invoked. The returned object is stored in the cache based on the key on the top. I can use the Spring expression language. I can say, okay, @cacheable. And if the name has a length of less than 10 characters, then cache the value, you know. I'm using the Spring expression language. I can call any bean. You can use the beans to, you know, whatever you want. You could say, oh, if the moon is in the same constellation in the sky as the sun or something like that, then cache the bean. You can do anything, okay? The opposite is true as well. You can evict records. You can say cache evict, and that'll delete the data from the cache, you know, when you call that method. So if you delete something from the database, you want to also delete it from the cache so you have no stale data. Okay, 3.1, we also introduced really good support for Servlet 3.0. Lots of different web support there. We upgraded support to 3.0 for servlets, so if you're using Tomcat 7 or Glassfish 3, for example, then you'll have good choices here. How many of you guys are using a Servlet 3 container? Oh, guys, comme c'est déprimant. Oh my God. You should definitely try and use a Servlet 3 container if you can. It's awesome. The speed benefits of certain kind of use cases that have to do with asynchronous I/O, you know, perfect. You need that. So Tomcat 7 is a good choice. We support also XML-free web applications now, right? So you don't need web.xml. This is a Servlet 3 feature. Spring builds on top of this. And then, of course, we've exposed a lot of new functionality in Spring Mvc 3. Another big feature from 3.1 is that we moved most of our code was already on GitHub. If you go to github.com/springsource, you can fork, make changes, do whatever you want. And we also moved the Spring framework to GitHub, right? And so the activity on GitHub has been amazing. We've seen so much activity there. So this has been a very good change. 3.2, okay. So first things first, 3.2 was released last December. And we wanted to have a lot of new features in there. And we do have a lot of new features, but we don't have as many as we had hoped that we would, okay? We wanted to support Java EE7 levels of compliance, you know, API, and we wanted to support Java SE8. Well, turns out that the Java EE7 and Java SE8 are both very, very late, years late. We're talking 2 or 3 years now of just late. Okay, so we couldn't really support it if it's not GA. And then also, some of the features that were going to be in those releases have been removed. Do you remember that at one point there was discussion of supporting cloud features inside of Java E7? Well, that's gone now, right? They're not doing it. So we can't support it in ours there that way, you know? So the scope of Spring 3.2 was smaller. That's why we were happy to release it, you know, when we did. Spring 3.2 ships with lots of really great refinements for web applications, however. Web applications are the main theme, I would say. There's other stuff. We moved the build to Gradle. How many of you guys have ever tried to compile Spring Core? Oh, it's so disgusting. Like, oh no, really, it was terrifying before, okay? Like, every single time you tried to compile Spring, like an angel died, you know? It was really bad. Really bad. Because Spring Core has to handle lots of different versions of classes, We support Hibernate, 3 and 4 and 4.2, and we support different ranges of compliance, right? JPA 1 and 2, JSF 1.0, 2.0, 2. Whatever. So we have lots of compliant, sometimes incompatible versions. That's a hard problem to solve. Most people don't have to solve this problem. They don't have to support ranges of APIs. But Spring, because it does lots of backwards compatibility, so our build process was, whew, holy boy, it was just disgusting. So now it's Gradle. You can actually go get the code on GitHub, clone it, and then go run Gradle, and it'll build. That's amazing, big deal. So it's even easier to feed back. Lots of Spring Mvc stuff. We'll look at that shortly. One of the nicest parts about Spring 3.2 is the support for asynchronous web applications. Okay? You guys, I think, probably know the history, right? So initially, servlets and in general, server architectures were based on the idea that when a request came into the HTTP server, the servlet container took the request, handled it, and then in the same thread sent back a response. So you listen to the server socket, you get the input, do some processing, and then send the response back. This works great if your requests are quick, in, out, very quick, But if you're doing a long-lived connection, which is very common with AJAX, or WebSockets or these kind of things, if you're doing a long-lived connection, you don't want a thread being kept open for I/O, right? You want to be able to divorce, to separate the threading in the server from the requests that are being come in. So what we did based on Java NIO in 1.4, you've probably noticed that the big trend these days is now to have asynchronous event-driven servers. Okay? So the idea is I get a request, and then I can either handle the request in the same thread, or if I know that it's going to take a while and there's not going to be any I/O activity, maybe the HTTP server wants to do some processing in the background before it sends a response, no problem. Put the I/O on the, basically a channel in I/O. Let the work happen there, and when something of interest happens in the channel, wake up the thread. Make the thread wake up and then send a response. So now you have a request coming in on one thread, put it to sleep, maybe do some work, who knows, and then when you're done, open up another and send the response back. But in the meantime, that thread is free to handle other requests from the server. So your server, you can have just, most Java application servers can only handle a couple of thousand threads. You don't want to keep more than like 2,000 threads open at the same time. You don't have to now. Right? You can handle a lot more requests, even if they take a long time. And so Servlet 3 embraces this architecture. It embraces it. It makes it so that if you want to, you can write an application using Spring Mvc or a Servlet 3 that takes a request and then does asynchronous responses. Servlet 3 support inside of Spring Mvc 3.2 is now here. This is what we have now. So here's an example. Okay? This is a Spring Mvc controller. A long-lived request might come in, for example, to handle parsing or processing a file. And then in the controller, we return a callable, which is basically just a runnable that has a return value. Okay? Spring Mvc will take the callable, and then in the background, it'll handle the processing. And then the thread that's on the server, for actually handling it, can just continue handling other requests. When the callable is finally finished, it can return a value from the Spring Mvc controller, just like normal. Okay, so here I'm returning a string, which will be used to resolve a view, which will be displayed to the client. This is very good. This syntax, this approach, is very good, but the thread is still managed by Spring Mvc. Another common use case is I want to work with a thread outside of Spring Mvc. Okay, here I have a request endpoint. The deferred result in Spring Mvc, this is a deferred result. This is a regular, kind of interesting class. You create a deferred result. You might put it in a global data structure. Imagine a concurrent list or concurrent hash map, And then when something happens in the background, maybe you have a JMS feed. Some JMS messages come in, and you'll update some state. Okay, message comes in. You find the deferred result in your concurrent hash map. Set the data on the concurrent hash map, and that triggers, that causes the response to be sent. Okay? So this is good for having a web endpoint that deals with something that's happening outside of the web server. Maybe a chat system or stock ticker feed or whatever. Okay? And of course, we have this slightly more specialized version of this. Okay, so this is async task. This is a version of callable with more features. It's just like a runnable. But here, you can specify a timeout. You can say, if this method, if this processing takes more than a second, stop the thread, stop the work. You can say that you want to use a specific task executor, right? So basically java.util.concurrent.executor. You can use that. And then, of course, you return a callable, just as before. So it's just very convenient. You specify more, but it's the same thing. Another thing we did in Spring 3.2, if you're using REST inside of Spring, it's very common to use the except header. Except header gives you content negotiation. This is the way the web works most of the time, 90%. But you may want to support content negotiation based on the URL. Maybe it's .xml, .json, whatever. Or you support a request parameter. Maybe I want to say format equals XML. So you can plug in, you can use different strategies now for content negotiation with REST. That's supported by the Content Negotiation Manager. We also released support for matrix variables. I'm going to be honest with you guys, just between you and me, nobody else will see this, right? I didn't even know what matrix variables were before. They're a part of the HTTP spec. They're in the HTTP specification. They're not named as matrix variables. They're called path segment pairs or various things like this. So here I've got an example of the JFrog API, which is a Maven repository kind of thing. You can see I've got QA releases, and that thing in the middle is called a semicolon. Okay, semicolon. Build number equals 135 semicolon. This is not an ampersand. It's not an and symbol. Here I'm actually using semicolons to specify variables. And this is supported. This is valid HTTP URL, so we support that. Another common use case is for lists. I have a list of values, 1, 2, 3, 4, 5, and I want to encode that in the URL. Down here, like in the Stack Exchange, Stack Overflow API. So here's how you support that in Spring Mvc. You say at request mapping, blah, 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 find pet, and then of course the matrix variable is what you're using. You're saying I want to get the matrix variable Q injected into my controller. Okay? So Q is, if you look at the URL, /pets/42, semicolon, Q equals 11. In this case, Q will equal 11. You can also access just all of the matrix variables, all of them in a map by just injecting a reference to the map. Questions on that? On this stuff so far? Okay. Another thing we did, and this actually is very, very handy, and there's a webinar that you can check on youtube.com/springsourcedev. There's a video there, okay? All about this stuff, the mock MVC test framework. Here's the server side. So what this does is it lets you create a Spring Mvc dispatcher servlet and let you set up the application context just like you would normally, and you can exercise your Spring Mvc controllers, test them, while executing the dispatcher servlet. So this does not start up a server. It's not a full server. All you're doing is running your controllers inside of Spring as though they were in the server. This lets you write unit tests that are sort of more integration test oriented, and they're very, 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 very fast. Okay? So here I'm using the mock Mvc builders and the mock Mvc request builders, etc. Those static import URLs give you a fluid DSL for creating tests. I can create a mock Mvc object by using the web app context setup, static import method, pass it the application context, and then build it. And then from there, I can actually, I can test. I can actually assert behavior by testing the endpoints and seeing if that matches the behavior of the controller that we have configured. Very, very convenient. This is the server side, okay? On the client side, as a client of HTTP resources, I can use the Spring REST template, which provides very, very clean one-liner support for invoking HTTP methods. I can use the REST template. I can pass it to the mock REST server.createServer, and that gives me a mock server that I can call to. Okay, so I can say, hey, if I go to /greeting, I expect that I'll get a successful plain text response with the value hello world. Okay, so that REST template now has a knowledge of what the server is doing, and it can be used to verify. Okay, so now we're looking at Spring 4. Do we have any questions on the stuff we've covered so far? I want to make sure I'm not going too fast, you know? Anything? Okay. Okay, here we go. Spring Framework 4 is due this year, end of the year, okay? We have support for Java EE 7 and Java 8. Awesome. I can't wait for Java 8. That's going to be so good. We have support, of course, for, as a theme, we're supporting event-driven architectures, event-driven applications on the web to do things like WebSockets, and in the background through events in the application context, etc. This is just, a lot of this will be based on improvements to the existing support, okay? But some of this will also be new stuff that you haven't seen before. The application events mechanism, how many of you guys have used the application events? Basically, you have the ability in Spring to publish messages within the application context, and then components in the context can receive those messages and react to them. This is a good way for doing asynchronous communication between components in the same application context, and it doesn't require JMS or anything. WebSocket support, based on the new JSR, will be there as well. We'll support that inside of Spring Mvc. And we intend to improve the Groovy support in a lot of different ways, right? But also, one example is to have the Groovy bean builder inside the core framework. The Groovy bean builder, by the way, so you guys know we have Java configuration, we have Spring Scala, which gives you the support for configuring things using Scala. We have annotations where you can say @component, @service, @repository, @controller. These are stereotype annotations, right? You can scan them and Spring will pick them up for you and arrange them. And then we have the Groovy bean builder, which you can use Groovy to configure your application. All these different ways of configuring your beans can be used together. Oh, and XML. You can use all of them together. All they do is they tell Spring, okay, I have a bean, here are the properties, here's the life cycle, the scope, and they can all live together in the same namespace. They can all see each other. So these are all just different ways of telling Spring about that information. At runtime, though, there's no difference. It does not matter to Spring if your bean came from XML or if it came from Java configuration or anything. So, if you guys want to follow along, of course, you're more than welcome to. This stuff is being worked on right now. People are working on this right now. Okay, so this is a good time. If you have things you want to see inside of Spring 4, definitely encourage the communication. I definitely encourage you to check out the Jira, check out the forums, etc. And make suggestions if you have use cases that you want to see solved. Okay, so have you guys looked at the Java 8 stuff? Some of the great stuff in Java 8? Really, really powerful. I expect a lot of people will be using Java 8. I hope you guys get Java 8, ASAP. Java 8 provides support for lambdas or closures. In particular, it supports something called single abstract method functional interfaces. Okay, so if you have a callable or a runnable, these define one abstract method, a method that has no body. And they have one method, and they're basically an interface. In Java 8, those interfaces are eligible to be used as lambdas. They can be used as anonymous functions. Okay, you don't have to provide the full anonymous class. You can just create a function. So all the places in Spring where you've used single abstract method functional interfaces, like the JDBC template, JMS template, all these things, all these kinds of callback-oriented things, suddenly you can use lambdas. It makes the whole framework seem much, much, much cleaner. Okay, you don't have to. You can get rid of all that anonymous inner classes, all those anonymous inner classes, and just use lambdas. Very, very, very clean. And that support you get just by upgrading. Just go to Java 8, and you can already play with it. Okay. Stephen Colburn worked on he's the guy who created Joda Time. You guys use Joda Time? Yeah, see? Very smart. I love this guy. Joda Time's amazing. It's a very, very good improvement. And Spring Mvc already supports Joda Time, and it supports it for conversion as well as validation in the controllers. We will support it. We'll support the new JSR 3.10 as well. So this is basically the same API. Well, I mean, it's got the same features as Joda Time. It's not the same API. But that will be very, very powerful, and we'll support that natively as well. Back here, we had, I showed you guys the REST template a little bit. Do you guys know the REST template? It's a object that you can use, like I said, to call RESTful services very, very conveniently. It's currently using synchronous blocking I/O because it's based on the JDK. But as Java SE8 will have a much better asynchronous NIO-based HTTP client, our REST template will also feature support for this. So you can do non-blocking client-side calls to RESTful services. Parameter names, you saw back here. Yeah, there. See where it says matrix variable int q? The variable name q at runtime disappears unless you have debugging symbols on. So if you compile your code and you don't have debug symbols, then Java has no way to know what q is. It just sees an integer. It doesn't know what the name of it is. So you can actually specify the variable name if you want. Most people will not. They just do this. They say matrix variable int q. By default, you will probably have debug symbols, so this works all the time. But it's not guaranteed, you understand? There's no Java reflection API that will let you access the names of these variables. So if a request parameter comes in from HTTP and the parameter is called q, Spring Mvc may not know which argument to map that to in the argument controller. And this happens all over. We have request params, path variables, matrix variables, etc. You know, lots of different places. In Java 8, we'll have a built-in way to look at this information at runtime, guaranteed to work. So we'll have that support as well. So it'll be guaranteed to work all the time. And then of course the new, JSR 166, whatever the new version, not Y, but the second part, right? The upgraded java.util.concurrent support that Doug Lee is working on. We have great support for task executors. We'll incorporate support for that fork join stuff as well inside of our Spring 4.0 release. Of course, we're going to support Java E7, right? That's a big, we're a very big stakeholder in that. We believe in a lot of those parts. So JCache 1.0, which is, we already support JCache. If you're using Spring 3.2, which came out last year, you can use JCache before, years ahead of everybody else, which is kind of ironic. We have JMS 2.0 support. JMS 2.0 has a very, very nice client context. They've taken, JMS itself has not been updated in 10 plus years. So it's very nice to see a new release. And they've done some very nice things. They've created a client for JMS that works in principle kind of like the JMS template. It's very, very powerful. We'll support using that with transactions just like with JMS template. JPA 2.1, nice. JTA 1.2 and the Bean validation API. All this stuff will be supported, okay, where appropriate, as required. And we're working on that now, so please check it out. If you're using Spring 4, you can still work with Java 5. You don't need to use Java 8. But if you are on Java 8, it works nicer, okay? It's not required, though. We will compile Spring with Java 8, though. So we're going to be compiling backwards compatibly. Here's one proposed syntax for JMS support. It's declarative consumption of resources. You can already do this with the message listener containers in Spring using XML. You can say JMS : message listener container and then specify a bean and a method. When a JMS message comes in, the method gets invoked, voila, you're done. But now you have an annotation, so it's even more declarative. If you're using Spring integration, then of course this will seem sort of, because you already have basically this functionality right now with Spring integration. So it's a nice feature, good stuff. WebSocket support, I expect to be one of those big, very, very useful use cases. The JSR 356 will be in Java EE7. We expect to see adoption inside the application servers fairly quickly, right? Because most of these application servers already have a proprietary way of doing WebSockets. So all they have to do is adapt that API to this new spec. So that shouldn't be very hard, and we'll support that within Spring Mvc. Resource caching. This is a big deal, actually. If you look right now if you go to Google and look for Spring Bakehouse, you might even search for This Week in Spring. There's something called Bakehouse, which provides a very nice resource management API for Spring-based applications, providing JSP tags and everything. Have you guys heard of JAWR, jar, from years ago? That's another example of this. You have the ability to concatenate and minify JavaScript. You have the ability to gzip compress it, perhaps. If you want to use less, L-E-S-S, for CSS scripts, you can process less scripts and convert them into CSS. You can use TypeScript and CoffeeScript, right? So these are different examples of things that you want to support in your web application. You want to have automatic compilation and minification and gzip compression of your resources in your web application. You already have this kind of support if you use something like Bakehouse, which is very nice, or if you're using Grails. Grails already has a resource asset pipeline, so that's very, very, very powerful. We'll have support for this inside of Spring Mvc, is my point. We don't know what it looks like right now. If you have ideas, definitely contribute. Yeah?
Do you know about WRO4G?
WRO4G. So the question is, do I personally know about WRO4G? No.
It does exactly what you explained us, and
Yeah.
it replaces with preprocessor and postprocessor
Yeah.
JOWR.
Yeah.
So you could probably look at it and have some ideas about it.
Perfect. Okay, that's a great example. The point is, there's a lot of people who are trying to solve this problem who want to provide them a solution, okay, in the framework. So yeah, definitely I will look at that. One possible definition, one possible thing that a lot of these things do is they require you to define the bundles. A bundle might be, you know, this JavaScript, and this JavaScript, and they get minified into one script at runtime. That usually happens inside the JSP pages, which is not good because you want to be able to define them outside of the JSP so that in theory you could do it at build time as well as at runtime when the application starts up. So we'll see about that. I'm not sure, we're not sure yet. And this will build on top of the support that Spring already supports for handling e-tags, okay? Content negotiation and state checking. So if the resource on the server has not been modified, then just serve the client local cached version. Some of that support will be built in as well. It's already there, and we're going to improve upon it. I mentioned Groovy support. There's obviously lots of different parts that we can do here. We could support Groovy language statements just like we do Spring expression language. We already have the Bean Lang API, the Lang namespace in XML. The Groovy Bean Builder itself, we will expect to see that inside of Spring Core. So yeah, good support there, right? New support. If you have ideas, again, now's the time. Okay, so I think that covers everything I wanted to talk about, leaving us with just 3 minutes, which is hopefully enough, for questions. So please, I'll take any questions now. And also, before I forget, don't hesitate to reach me on Twitter. Like I said, at StarbucksMan, I'm very happy to talk to you guys if you have questions. And if I don't know the answer, which, happens all the time, then I will know who does, all right? There's probably a good answer, and I can talk to people for you. So please let me know. All right, any questions? Maybe? You guys don't have any? I have questions. I was here. I was paying attention, and I still have questions. Like, where did he get that cool shirt? How do I get one? What's it all mean? What's the meaning of life? And why is the Wi-Fi so really bad, No questions at all. All right, guys. Oh, yeah. I'm sorry. Hi. Miss?
Hi. I'd like to get details about the event mechanism, application event mechanism.
You want me to do what? With the
application event mechanism?
Yes.
You talked about that?
Yeah.
Just some details, maybe?
So right now, if you're using Spring right now, today, from Spring 1.0 and later, or maybe 1.1, we've had an event mechanism where you can say, I am an application, I am a class, I'm a bean. When you register a bean that implements the interface application context event aware or something, you can say, you can receive a message, an object, coming from another class, another bean. So for example, what if I have a customer service object? It's a service that handles customer processing, okay? And then I have a web app, I have a Spring Mvc Controller. Well, if the Spring Mvc Controller wants to communicate with the customer service, it can do a couple things. I can invoke a method directly, or I can publish an event. I can say, new customer event, new customer signed up event. And the event is published in the application context, and then can be, all the classes that implement that interface to listen for events, they're given the message, okay? That's already there. In Spring 3.0, we made it so that you could filter messages by type. So you can specify a type parameter for the class. You can say, I only want customer signed up events in this class. I only want this type of event there. So that's already there. That's a good feature. There's a lot of possibilities here. One is maybe having something that works more like Spring integration. Spring integration already provides the ability to work with enterprise integration patterns like JMS, AMQP, XMPP, web services, REST, file systems, etc., tweets, These are all different event producers, and you can become a consumer, a sink, an event sink. That's one perhaps strategy. Another is perhaps to have a more event-like mechanism, eventing mechanism kind of like that in Grails, so that you have the ability to plug into other things as well. There's a lot of different pieces to this. I don't know what the specific support will look like, but the idea is to improve upon what we have right now and to provide integration with the web and WebSockets and things like this. Right? So there's a lot of parts to that story. Yeah. Any other questions? Okay. No other questions? Okay, good, because we're out of time. Ça y est, hein? Merci, thank you.